This is our last section in module 8, and we're going to talk about logic gates and logical circuits. So this lecture note, we have a bunch of different exercises which motivated the solution for two primary types of problem. One, given a Boolean expression, whether it is possible to draw a circuit that represents the logical expression, or given a circuit, can we interchange the concept of the circuit with Boolean expression? So we will talk about only the three basic type of logic gates. Those logic gates are called inverters. So in an inverter, if you input a variable, you will get the complement of the variable as output. If you have two variable input in an OR gate, then we get the Boolean sum as the output. And in an AND gate, if you have two variable input, you get the Boolean product as the output. So with the help of these three circuits and the Boolean operation, we will be able to interchange a given Boolean expression in terms of a logical circuit, and given a logical circuit, we will be able to interchange it back to a Boolean expression. I'm going to skip all these explanations and the examples done in this lecture note. These are for the reader to see on their own, and I am just going to go directly to the exercises that I have in this lecture note and solve them and show you the process. The process should not be any complicated. It's actually fairly simple in order to change a Boolean expression to the logical circuit, or given the circuit, change it to Boolean expression. So our first example is asking us find the output of the given circuit. As long as we remember the pictures with the associated gates, it's not at all difficult. So as I see in this picture, X is being input to an inverter, which is the complement gate. So the output after going through the gate is going to be X bar. Similarly, Y is getting input in the inverter. So the output is going to be Y bar. When I have X bar and Y bar both being input in the AND gate, the output is going to be the Boolean product. So this is going to be X bar dot Y bar. And see, that is the input now into the inverter, which is the complement gate. So my final output is going to be X bar dot Y bar complement. So this is what the Boolean expression that corresponds to the Boolean circuit is going to look like. What I will do as an extra step, I will rewrite my final output X bar dot Y bar and try to simplify this thing. So first I'm going to use the De Morgan's law for the outside-most complement, and I'm going to write outside for us to review this in later time and understand what do I mean by that. So De Morgan's law tells me if you have a product of two variables, then under De Morgan's law that becomes a sum. So you get X bar bar, Boolean sum Y bar bar. Double complement tells me X bar bar is X plus Y bar bar is Y. So in order to simplify this circuit, one could have started with two inputs, X and Y, in both going in the OR gate. So this is my input X, this is my input Y in the OR gate, and I will get the output as X plus Y. And that would have simplified this complicated circuit that we started with. Answers my question for the first one. I have a similar example. This time the circuit is even more complicated. So I look at this circuit, but in order to change it to a Boolean expression, we just have to go through each input and the logic gate and write down the corresponding output. So let's start with the first input being X in an inverter. The output becomes X bar. Y goes to the AND gate directly. Z goes to the AND gate directly. So X bar dot Y dot Z is my output after the AND gate, which is going through an inverter one more time. So you get to say that this is X bar dot Y dot Z whole bar. Then I look at the parallel circuit in the bottom. X is going through an inverter again, so it is becoming X bar. whereas y is going through the directly going through the OR get, and z is going to the inverter first, so it becomes z bar. Now I have x bar, y, and z bar going into the OR get, so I'm going to get x bar plus y plus z bar. So we have x bar dot y dot z whole bar and x bar plus y plus z bar both getting input into the AND get, and thus the final output is going to be x bar dot y dot z whole bar dot, because it's an AND get, I get x bar plus y plus z bar. So let's try to simplify it as much as possible. We are done precisely finding the Boolean expression, but we would like to simplify this thing a little bit more. So first remember x bar dot y dot z bar, I can use the De Morgan's law and write it as x bar dot y bar plus z bar, which is going to be one more time use of De Morgan's will give me x bar bar plus y bar plus z bar. So that is going to be double complement. So x bar bar is x plus y bar plus z bar. So if I look at the final output expression now, we're going to go ahead and say that the output is going to look like x plus y bar plus z bar dot x bar plus y plus z bar. So one other similar circuit that will give me the same output, I'm going to draw it now. So see that for the first one, I need x as an input. I need y to go through the inverter first, because you want it to become y complement. Then you need the same thing for z to go through the inverter to make it z bar. And then I can say that all of them are being input in OR get. So let me do that picture one more time. And I can actually go ahead and say that this looks something along the line of this. And because I need OR get at this point, I'll go ahead and do the OR get here. After the OR get, I would need a final output. But let's first do the parallel circuit, and the parallel circuit will need x and z to go through the inverter first, but y can go through. So I will say x going through the inverter, becoming x bar. Y can go through directly. Z will need to go through the inverter in order to become Z complement. And then I'm going to let them go through the OR get one more time. So this is what we are looking for. And this output will go and will now be input to an AND get to finalize the process of the circuit. So this new circuit is an equivalent circuit that is going to give us the same Boolean expression as we have started with. So the other two problems that we have in this section are problems where we are going to be given with a Boolean expression and we're going to draw the circuits. So the first one is x plus y bar times x. So we'll start with the input x and input y, and I'm going to first let them both go through the OR get. And after the OR get, the output is clearly going to be x plus y. But once I have x plus y, I want it to be inverted. So let's let that go through the inverter. And then I will need one other input, a parallel input for x. And I will let the output of the first circuit and this x input go through the AND gate to become the output x plus y bar times x. The next one is a little easier. You just need to invert x and add y with it. So let's have the input x. Let's let it go through the inverter. So now it has become x bar. And y is your direct input this time. And because you have the Boolean sum, you are going to let it go through the OR gate. And that is going to give you the output of x bar plus y. That answers our question. And this concludes this section as well. It concludes our module 8.